So, welcome to Farmwall's National Science Week event, which is a live PD on microgreens and microgreen experimenting. We're running this event mainly for teachers to demonstrate why microgreens are a really useful tool for experimenting in the classroom, and also why microgreens are so fantastic for starting a discussion about urban farming and farming for the future. Before I start, I'd like to begin by acknowledging and paying my respects to the Wurundjeri people, who are the traditional custodians of the land which I'm joining this meeting from today. And I'd also like to acknowledge and pay my respects to the traditional custodians of all the places from which people are joining this meeting today. And I would also like to pay my respects to elders past, present, and emerging. So I'll start by talking a bit about what Farmwall is, and then what I'll do is talk about natural ecosystems and aquaponics, and then I'll talk a little bit about microgreens and what they actually are and what they're so good for. I'll also talk about the benefits of greenery indoors, and then the power of urban farming, and then I'll showcase the Farmwall Microgreen Experiment Kit. I'll show you how to use it, and then I'll talk about some points of interest, scientific points of interest that you can gain from the Microgreen Experiment Kit, and also how to run an experiment in a classroom with the kit. So, actually, Farmwall is a social enterprise which we focus on urban farming, and we want to ensure that future food systems are sustainable. And the way we try to do this is by combining technology and science. And what we're doing is looking to take a considerable load off of regional farmers and on regional agricultural practices, which have been the norm for centuries now, by turning our cities into food producing ecosystems. And if we do that properly and effectively and with the best practices and best technology in mind, then what we can do is a few things that haven't been done by traditional agriculture, especially in Australia, which is increased biodiversity, both in the city and rurally. And we can also really benefit the economy and actually future-proof it for any of the problems that will arise in the future from global warming. And you also, if you're farming in the cities and using the right technology, you can shorten transport distances for food to get from farm to plate, and you can also make food distribution networks a lot more efficient. So in doing that, you reduce the carbon footprint of agriculture and feeding your society and communities. And on top of that, you can really capitalize on a high level of control in your agricultural practices so that you can get really, really rich, nutritious food grown in a small amount of space. And not only that, you can do it in a way that connects really well to your local community or your urban community. One of the ways that Farmwall really likes to do this is through aquaponics, which there's hydroponics, which is phonics growing plants in water, and aquaponics is growing plants in the water, which also has fish in it. So instead of just having water that you add nutrients to, what you do is you have the fish in there, which is where the aqua part comes from, which is aquaculture, and then the fish essentially feed the plants. The way this works is that if you follow this little cycle on the screen here and start at step 1, the first input is to feed the fish. The fish eat, and then they produce a lot of ammonia-rich waste, and then in the fish tank or the fish system or pond, whatever you're using, there's good bacteria, naturally occurring, really good bacteria, which works to convert that ammonia in the waste to nitrites and nitrates. Those nitrates are what feed the plants. So that's what you can see in step 2 is those nitrates that eventually in step 3 are in the water, and the plants through their root system suck those nutrients up. And in doing that, the plants are cleaning the water for the fish, and that brings you around to step 4, which closes the cycle. What you end up doing is you don't have to use any artificial fertilizers, you don't have to use any chemicals which are foreign to the environment, and the plants can grow really, really efficiently, really, really quickly, and they end up being really, really nutritious. So it's essentially a closed loop system with two inputs. Those inputs are at step one, which is feeding the fish, which if you source fish food or find a way to feed the fish which is sustainable and environmental, then that makes that input closed looped or sustainable in its own sense. And then the other input at step three is that you also need light, which will hit the plant. So if you're doing this outdoors, you use sunlight, where it's usually done is indoors, where you use artificial light. What Farmwall's done in the past and are still doing now to do this is to create aquaponics systems, which are closed loop systems which can work indoors. And one of the ways we've done this is with these large Farmwall systems, which you can see on the screen in front of you. I guess it's hard to describe, but if you think of the cycle that we just spoke about, the fish are in that tank at the bottom, you feed the fish, and then their waste is in the water, and it's pumped from that water to each of the levels in that shelving unit or Farmwall unit. And then that water runs below the plants, or in this case, the microgreen trays that are growing there. Those microgreens, or the plants in the top shelf, suck up all the good nutrients, clean the water, and then the water passively drains back down to the fish. It requires pretty much no chemicals whatsoever, with the exception of a small amount that you might need for fish care, especially when you're starting to establish the fish tank. They're really easy to use and they're really low maintenance. You have a lot of benefits in terms of pests and diseases. You don't have to deal with the same pests and diseases that might occur in outdoor growing or agricultural practices. And the water use, even though you've got that big tank of water at the bottom, it's actually really minimal in the long run. So instead of watering your crops outside all day for months on end, waiting for your vegetables to grow, or pumping or growing in a really wet area where it rains all day, you just have that fish tank there, and you don't actually have to bring in a large amount of water all the time. The system that I've just shown you, I guess, is Farmwall's large-scale version of an aquaponics system, and what we're now trying to do is bring it down to a smaller scale so that it can be really useful in classrooms and in homes. So before I get into that, what I thought I would do is talk a bit about microgreens and what they actually are, because for us at Farmwall, it's our day-to-day and our bread and butter, but we realise that there's actually a lot of people out there who still aren't sure what a microgreen is, or the only time they've seen a microgreen is maybe when they've gone to have a really nice brunch, I guess pre-lockdown, gone to have a really nice brunch and had a few microgreens sprinkled on their breakfast. So basically a microgreen is a plant in its early stages of growth. So for example, when you're growing microgreens like broccoli microgreens, you're growing a tray of broccoli microgreens, actually hundreds of broccoli plants, which if you were farming them using regular practices, you'd have to wait months and months to grow one large plant and then remove the floret or the head of the broccoli. In a tray of microgreens or in a cup like what you can see in front of you, that's actually individual broccoli plants, so usually hundreds of them. They're really small and they're really, really highly nutritious because they pack a lot of their nutrition into that tiny little plant. When you eat them, you get a whole bunch of them, a handful or a snip of them, or you can have a whole tray made into a pesto or a salad. And not only is that like multiplying the nutritional benefit of one broccoli plant, but they're actually more nutrient dense. So one broccoli microgreen can actually have up to 40% more of all the nutrients that come in a mature broccoli. Growing them is really, really quick. So instead of planting a broccoli plant or seedling and then waiting weeks to months for it to grow, from seeding the microgreen through to eating it or harvesting it is usually 7 days. And it depends on different kinds of microgreens and different plants that you're growing, but for the most part, it's 7 days or 7 to 10 days to harvesting. And on top of that, you can grow it in really sustainably sourced growing mediums, which are either recycled or they don't have any kind of negative environmental impact. One of the other really good benefits of growing microgreens, especially if you're growing them indoors in your home or in a classroom or in the office like we do here, is that they have the same benefits that regular plants do, indoor plants, or having a really nice natural outdoor plant setting in your home. They reduce stress and they increase concentration. There's actually research that shows a really strong correlation between time spent living in natural settings and a reduction in stress. And then concentration levels and productivity and creativity are all increased when you have a greater access to green space, which is something that is often hard to do when you're living in a city or a built up area, is having very quick access to green space. So having plants indoors, or with what we're talking about, microgreens indoors, can give you that access really easily. It's also been shown that psychological distress and symptoms of mental health issues like depression and anxiety and mood disorders, they've all been shown to decrease when there's an increased presence of plants in an indoor space. That includes a workspace or in a home. On top of that, plants clean the air that you're breathing. This is something that we owe to large forests and ecosystems out there in the world, cleaning the air that we breathe that circulates all around the world. For example, people often say the Amazon is the lungs of the earth because of the air cleaning and the sequestering of carbon that it does in the atmosphere. It's the same for any kind of plant indoors, and it's exactly the same for microgreens indoors. So having them inside in your home or classroom also actually cleans the air. It's actually really good for you long term and reduces a lot of the negative health effects of having pollutants in your air indoors, or not having fresh air indoors. And then another thing is that there is a very, very clear link shown through research between nutrition and having access to really highly nutritious foods and an improvement in mental health. So I realized that was kind of a lot of different things to bunch all together in one single spiel about the benefits of greenery. But that's kind of an overview of why we really care about this and why we think it's a really useful thing for everyone to have access to. So the Farmwall Microgreen Experiment Kit is, like I said, something that we've done to try and bring to a really small scale all of the benefits and really exciting things about growing microgreens. And we think it's a really good way to be able to highlight a lot of the cool scientific things that are going on when you grow microgreens. The kit itself comes with about 30 different parts. So that includes 3 different growing mediums, which is what you grow the plants in, which includes hemp cubes, which you can see in the top left of that picture. That's a grid of hemp cubes there. And what they are is a waste product from the hemp industry, which we source from Canada. And instead of that waste product from parts of the plant that aren't used in the hemp industry and throwing it either in large-scale composting system or into landfill, we can recycle it and use it as a growing medium to grow plants in instead of soil. So you get some of those cubes. You also get soil pods if you'd like to try out growing in soil the traditional way as well. And then you also get clay balls, which are another inert growing medium. So you get a bag of those. You also get a bottle of plant fertilizer, which is Farmwall's own plant fertilizer made from insect waste. And then it's bioactivated, so it actually feeds the soil with microorganisms that will help keep the soil alive even after you stop fertilizing it. You also get plant seeds, you get the pots and the cups that you can grow into. And then on top of that, you have access to an online course that comes with it as a short course with instructional videos, and it basically outlines how to use every single part of the kit. And there's a range of experiments which you can do with the kit. You can use it over several different lessons. What we think would be possible and what we've seen is possible is that you could go through all of the course content. You can go through the videos, learn a bit about plant growth, photosynthesis, soils, soil health, aquaponics, everything like that. And those are all things that come with the course, which also I forgot to mention comes on the Farmwall online e-learning portal, which you also have access to, and other resources that are on there. And then yeah, you can go through that together and then use the experiment kit to actually conduct your own experiments, to have a look at the way different seeds grow, the way they grow in different growing mediums, or perhaps in different growing conditions, if you'd like to change the light or the moisture availability. So this is an example of perhaps an experiment that could be run in a classroom, and I'm happy to completely admit that what I've done is drawn on my memory from doing science experiments in a classroom more than 10 years ago when I was in high school, and writing a scientific report from that. So having an aim, hypothesis, and then outlining your method, looking at the results and recording them, and then having a bit of a discussion about that. So what I've done is prepared a sample experiment, which I've got to show behind me. What I'll do is I'll talk about the experiment I set up, and then I'll close the presentation, and you can see on the camera what I've done. So the way I decided to design it was to have the aim of understanding the impact of just different growing mediums and also different growing vessels on two different microgreens. So I got rocket seeds and green mizuna. Rocket you're probably very familiar with because it's in all the supermarkets. Green mizuna perhaps not so much, it's another herb. And what I did is I sowed those seeds on the 3 different growing mediums that come with the kit. So that was hemp cubes, clay balls and soil. And then also did it in terracotta pots and the coffee cups that come in the kit. My hypothesis, so what I believed would happen, was that the clay balls would require more water because they don't store water as well. They do a really good job of wicking it up, but they don't store it. And I also believe that the seeds sown in terracotta pots, or the microgreens grown in terracotta pots, would require a bit more water because terracotta is porous, and so a lot of that water can evaporate slowly as it comes out to the surface of the pot and then evaporates into the atmosphere. So I got my microgreen experiment kit, I got the mediums prepared, I soaked them, I soaked the soil in the hemp cubes, which again is something that's shown in the tutorials in the videos that come with the course, and then I sowed all my seeds following those same instructions. I placed the terracotta pots in water with the coffee cups with water inside them, and I can show you that in a moment. And then I covered them for 2 days to germinate, and then uncovered them, and they had 8 hours of direct light on them. So what I've got on my right here is the experiment kit and everything that comes with it. That's the bag of clay balls and the pots, seeds, growing mediums, and our Farmwall's indoor plant fertilizer. And what I've got on my left here is the experiment that I set up. So what I've got here are rocket seeds that I sowed in soil, hemp cubes, and clay balls, and they're in the coffee cups. The way you use the coffee cups is you get these paper cups which come in the kit, and you do your planting in that, and then you place it inside the coffee cup, which retains the water. So you fill it with a little bit of water, and there's a water reservoir in there. That water wicks up into the growing medium through that cup and feeds the microgreens, or waters the microgreens. So I've got my 3 rockets there. And what I did was the exact same growing mediums in terracotta pots rather than the coffee cups. So that's rocket there as well in the middle row, in soil, hemp, and clay balls. And then this last row is terracotta pots, same growing mediums, but what I changed was the actual microgreen I was growing. So in this case, they are mizuna microgreens. Hopefully you can see that the rocket that I grew in soil and hemp have grown really nicely. They're not mature yet. These would have been sown 5 days ago now. So in 7 to 10 days, they would be tall enough for me to snip off and harvest and eat. What you can see is there's a really nice even surface coverage, and they all look really rich and green and dense. And I can also see from the cup being a little bit moist, so that they're well hydrated and they haven't dried out. In the same vessel and the same plant but different medium, which is the clay balls, it's actually sparsely growing. What I think is happening is that a lot of those seeds have dropped below the clay balls, and many of them have still germinated, because I know rocket germinates really, really easily and really quickly. What I think has happened is a lot of them are just slowly growing below there. In a day or two, they'll come out to the surface as well. So I should have that nice even coverage like these two here in another day or two. Moving to the next row, which is all the same plants and mediums in the terracotta pots. I have that same really nice even growth in the soil and the hemp cubes. So that tells me that the medium is definitely working and that it's okay to use either of the growing vessels. What happened was I sowed these on a Friday, left them in a tray of water, and then 2 days later came back to uncover them, and I noticed that the tray of water had completely dried up. Not only that, the surface of the terracotta pot was also dry. What that tells me is that in those 2 days, I probably should have checked the water, especially in these terracotta pots, knowing that it evaporates out of the surface of the terracotta pot. But it wasn't a huge issue in the case of these two, because the soil and the hemp cubes retain a lot of moisture really, really well. For the clay balls in the same medium, they've actually grown not as well as the clay balls in the coffee cups. They're sparsely populated again, which I think is still due to the clay balls, the seeds dropping down below them. What I suspect happened is the water that in the soil and hemp cubes was retained in the medium wasn't retained as well in the clay balls. So out of the ones that require a little bit more hydration, a bit more water, perhaps checking the water every day, I think this would be the most critical. Moving on to the next change variable, which is the green Mizuna. They're not as good as the rocket. So they're, again, a little bit spread out, I guess, and they've actually grown a bit leggier. That tells me two things. One is that they don't germinate as well as rocket seeds. I put the same amount of rocket seeds as I did green Mizuna seeds, and what I've got here is less of them germinating. So that tells me that there's a good chance the plant itself doesn't germinate as readily as rocket, or the environment that I provided was ideal for rocket, perhaps not ideal for Mizuna. Maybe the temperature wasn't quite right. Maybe the amount of moisture they had wasn't enough, or it was too much. And maybe the light they had access to wasn't enough. I doubt that the light was an issue. What I suspect is that the temperature or just the germination rate of the plant of those seeds wasn't as good as rocket. It's the same in the hemp cubes and the clay balls for the Mizuna. The spread isn't as even. The germination rate, I can actually see seeds that haven't germinated in there on the rock wall. And they're also a bit thinner and a bit leggier. That legginess usually suggests they don't have enough light. In microgreens, it's okay. You actually want microgreens to grow nice and long so that you can then snip them and have a longer microgreen to eat. But if you're growing vegetables or plants outdoors, you really don't want that legginess. You want it to have a nice, thick, strong stem to hold itself up before it grows into a mature plant. In the case of the Mizuna and the clay balls, I can see a lot of seeds that aren't germinated, and I can see that it's also quite sparse. And not only that, they're leggy again. So what I've learned from this is Mizuna, a little bit harder than rocket. Clay balls probably need more water, a bit more time to see that nice even germination. Soil and hemp retains moisture really, really well. And if you want a nice, easy crop to grow a really even spread of microgreens, rocket is probably the way to start, the one to start with. So that's it for my show and tell. Like I said, the water that the terracotta pots are in, it evaporated over the weekend, and it might have been a little bit too long for that to have happened. So if I were doing this in my home, I could look at it every day and water it every day. If it was in a classroom, then what you could do is do it on a Friday and see if you can retain that water level over the weekend. The seeds germinated quicker in soil, and that was definitely due to having higher moisture available. Most seeds in the plant kingdom require moisture to germinate. Not all, but most. If they're sitting in a little bit of moisture, not too much, like it's flooded, but a little bit, then they'll germinate a lot better. So that was probably the issue with the clay walls, is it was all drying up a bit. I had a consistent microgreen height in the soil and the hemp, but not the clay balls. Like I said, probably from the seeds falling down the clay balls. The germination was also a bit slower than what we usually like to see. They were grown in a grow room where the temperature is fairly consistent. What I suspect may be the case is that while it's colder now in winter, the temperature in that room isn't as high as it could be, or perhaps it fluctuates as the night gets really cold, and the temperature control we have in that room has to work really, really hard overnight to maintain a good temperature. So what may have happened is the cold also slowed down the germination a bit. That's one that I can only really check when the weather's warmer, and I can do the same experiment and compare them to see if temperature was an issue. So yeah, I would draw my conclusions from that. And if I was doing this classroom as a student, doing this experiment as a student in a classroom, then I would, yeah, those would be my conclusions basically. And I could maybe make suggestions or guesses about what another experiment would be or further research to figure these things out. For me and this experiment, I would want to figure out how much of an impact temperature had. So having a controlled temperature environment would be the next thing. So I just thought I'd put in a few more pictures of different microgreens growing in the same coffee cups, which are in the kit. I won't go through them all, but there's coriander there and there's some red cabbage, and they look really, really nice when they grow really well. And what you can do at the end of it all, I forgot to add this, is that now that that experiment is conducted, in a few days when it's done, I'm going to chop all those microgreens off and put them on my lunch, probably on Friday afternoon here at work. So that's the other thing you can do is once the experiments are done, your students can take them home, add them to dinner, or have them in their lunch, or you can have them all together in the classroom and have a meal together where you can add the microgreens.
Something we really like to do is link all of our work, all of our kits, all of our e-learning content to the Sustainable Development Goals. What I can do is maybe just leave that one up to you guys, but if you haven't heard about them, they're 17 goals developed and then guided by the UN, and it's kind of like the cheat code to fixing things for the future. So everything we do, we link it to the applicable goals, reducing poverty, solving food security issues, no hunger, health and well-being, stuff like that. And a lot of our educational content on the e-learning portal has lessons or exercises which link what you're doing with whatever kit you have to one or more sustainable development goals. Yeah, and then if you want to take it to the next level, this is the kit that I was talking about, the ecosystem kit. This is a tool that we in the past have sold for home use a lot, and what we're now doing is bring it into schools as an educational tool. You have an aquaponics system on one side, and that's the fish tank that you can see on the left, and then you have a hydroponics system on the right. So in the aquaponics system, you have your fish, feed them, their waste feeds the plants, so you're growing above. You can grow microgreens in a tray like you can see in the picture, or you can use a tank lid with holes in it that we provide, so you can put cups, terracotta pots or cups in there. And then in the hydroponics, you grow in these hydroponic nets, so you can grow leafy greens and salad greens and stuff like that. Yeah, what it comes with is a 12-week course. It pretty much goes from start to finish. The first lesson is, here's what you've got, unbox it, here's what every part is, and it comes with roughly 70 different parts, unique parts that is, but if you get a certain amount of seeds and a certain amount of pots and all that, it's actually more like 150 individual parts. And then it goes through what are aquaponics, what are microgreens, how to grow them, why light is necessary for growing, why your growing mediums can be different, and how to control diseases, or how to use them properly. Basically everything related to urban farming. So at the end of it, you graduate as an urban farmer. And by the end of it, you know how to grow things aquaponically on any scale, hydroponically on any scale. You also know how to make wicking beds, control all your growing systems, etc., etc., etc. It's a fair bit. The amount of content in there is quite a lot. So that's the next level up, I guess. If the experiment kit is good but not enough, and you want to scratch the itch a bit more, you can buy this and do this course either in your classroom or at home.
So how much was the course, Petra?
For the kit that's in front of you, for schools it's $5.95, and I'll have to get back to you on an exact number for individuals in the home, but I think it's the risk of getting this wrong is something more like $3.95. That's it. I realized we ended up going for about half an hour anyway, so thank you for sticking with me through that.
Oh, it's been really, really good, Petra. The information given us is really, really cool.
Cheers, thank you.